So you had to do 3 trig identity problems from your book, as well as some more factoring by grouping practice. I'm going to start with the trig identities. We're using the same screenshot that we used last time. So for number 6, they give us secant theta, and then parentheses cosine theta minus cotangent theta, and we want to prove that that's equal to 1 minus cosecant theta. Alright, well, looking at this, I don't have any straight up trig identities like a sine squared plus cosine squared or anything to plug into. So let's just distribute on the left, because I really don't have any other options. So if I do that, I'm going to get secant theta times cosine theta minus secant theta times cotangent theta equal to 1 minus cosecant theta. Okay, so we might not think that that really helps at all, but if I look, I've got this secant, and I also have a cotangent. And I know that I can write those in terms of sine and cosine. So if I rewrite this just using sines and cosines, this is going to be 1 over cosine times cosine theta minus, and then here I'm going to have 1 over cosine times cosine over sine. And the right side we can leave the same for now. Okay, remember, you just change how things look, so you don't move anything from right to left. And this is awesome because now these will cancel because they're top and bottom, and these will cancel because they're top and bottom. So here I'm just left with a 1, and then I'm left with a minus 1, and then a sine theta in the bottom. And right here, 1 over sine theta, well, that's just the reciprocal of sine, which is cosecant. And there we go, I'm done. Check. A little more difficult than the last ones, but still not too bad. Number 7. Very similar. They give us cosecant theta on the outside. And then I've got sine theta plus tangent theta equal to 1 plus secant theta. Okay, we're going to do the same strategy. I don't have anything to, straight up substitute right away, so I'll distribute on the left, and that will give me cosecant theta sine theta plus cosecant theta tangent theta equal to 1 plus secant theta. And let's try and write everything in terms of sine and cosine. So cosecant we can change to 1 over sine. And this is still times sine theta. 1 over sine theta. And then tangent is sine over cosine. And very similar to last time, I have stuff in top and bottom. So here this cancels, and here this cancels. So I'm left with 1 plus 1 over cosine theta. And the reciprocal of cosine is secant. So almost the same as number 6. This checks. And we have to do number 12. 12 gives me tangent theta over secant theta. And I want to prove that that is equal to sine theta. Okay, do not be tempted to multiply both sides by secant theta. We cannot do that. You cannot move things from one side to the other. But we always try and write things either in terms of an identity or in terms of sine and cosine. I don't have an identity right now, but I can break tangent into sine over cosine. And that's going to be all over 1 over cosine. Okay, you might think this doesn't really look like we're simplifying anything, but now it's nice because I only have sines and cosines on the left side, and I have baby fractions. All right, and I can get rid of baby fractions by multiplying by the baby denominator. So I'm going to multiply on the left by cosine theta over cosine theta. Okay, and this is okay because I'm only doing it on the left. And when I do that, multiplying by cosine theta over cosine theta, that's multiplying by 1. So I'm just changing how the left side looks. Okay, I'm not changing the value of anything. And that's nice because here my baby fractions cancel, but it also cancels in the bottom. So I'm left with sine theta over 1. And sine theta over 1 is just sine theta. So we are done with the trig identity proofs. Woohoo! Okay, and then we had to do some factoring by grouping. We had to do 1 D, E, and F. Hold on, let me get my worksheet. So for 1D, we had negative x cubed. Oops, that looks like a 5. Negative x cubed plus 2x squared minus 3x plus 6. Okay, remember we start off by drawing our line down the middle. And we always pull out a negative if we can. So if I look on the left, my first term is negative. So I'm going to pull out a negative. So I'm going to pull out a negative x squared on the left. And I'm going to be left with x minus 2. And then on the right, my first term on the right-hand side is a negative. So I'm going to pull out a negative here. And I'm going to be left with x minus 2. So then when all is said and done, I can pull out a factor of x minus 2 from both of my groups, and I'm left with a minus x squared minus 3, which you can leave like that. Trying to think of what else. If you really wanted to, a lot of people don't like negative quadratics. So if you want, you can pull a negative out of here and throw it in the front, and then this would become x squared plus 3. But either of these are okay. Alrighty, and then we had to do E. E gives me 6x cubed plus 4x squared minus 18x minus 12. Alright, so I draw my line down the middle. In my left-hand group, I can pull out a 2x squared, and I'm left with 3x plus 2. And on the right-hand side, my first term is a negative, my negative 18. So I'm going to pull a negative out. I'm going to pull a negative 6 out. And I'm going to be left with 3x plus 2. Okay, just a heads up, say you were looking at this on the right-hand side and you just pulled out like a negative 2, and you were left with 9x minus 6, or plus 6, I'm sorry. Obviously, if you look at your left-hand group and your right-hand group, those don't match. Alright, so this is clearly a factoring by grouping question because you can draw a line down the middle. So if for some reason your groups aren't matching, you might not have pulled out a big enough factor. Anyways, so now if I look at all my groups, I've got a common factor of 3x plus 2, and I'm left with a 2x squared minus 6. But I'm not done because out of 2x squared minus 6, there's a GCF of 2, so I can pull a 2 out, and then I'm left with x squared minus 3. Right? You can write the 2 in the middle, like that, but that kind of looks weird. We usually move the constant to the front, but either's fine. And then F. F gives me 6x cubed minus 18x squared minus 3x plus 9. On the left, I have a GCF of 6x squared, and I'm left with x minus 3. And on the right-hand side, I'm going to pull out a negative because my first term has a negative, and I'm going to plot a negative 3 and be left with x minus 3. So overall, I have a GCF of x minus 3, and I'm left with the 6x squared minus 3. But that 6x squared minus 3 has a GCF of 3. And I'm left with 2x squared minus 1. But that 3 looks weird in the middle, so I'll move it out in front. And now I am done factoring. And then on to part 2. We had to do A, C, and D. Now notice, for 2 we're actually solving. So we're going a step further than just breaking it up. We actually have to find x. So for 2a, I've got 3x cubed minus x squared minus 12x plus 4 is equal to 0. So I'm still going to draw my line down the middle, and I'm going to factor. This has a GCF of x squared. This is going to have a greatest common factor of negative 4. All right, pull out the negative, and you're left with 3x minus 1. So now I've got 3x minus 1, and then x squared minus 4. And I'm not done because x squared minus 4 is the difference of perfect squares. That factors into x minus 2 and x plus 2. And now I'm actually solving. So I need to take all these factors and set them equal to 0. So just like normal factoring, if it says to solve, you actually have to solve for x. So here I'll add 1 divided by 3, x is equal to 1/3, x is equal to 2, x is equal to minus 2. So if you stopped here, that's not 100% correct because you actually had to find x. Alright, C to C, that is going to give me x cubed plus 5x squared minus 9x minus 45 is equal to 0. Draw my line. GCF of x squared. Oops, left with an x plus 5. Here I'm going to plot a negative 9 and be left with x plus 5. So now I've got x plus 5, x squared, oops, minus 9. Notice, even after I do my factoring by grouping, I usually have a GCF or a difference of perfect squares that I still need to factor, like right now. And I'm not done, I actually need to solve this. Remember, this is called the zero product property. If things multiply to 0, then one of them has to be 0. So I get x equals negative 5, or x equals 3, or x is equal to negative 3. I think I pointed this out in the last video. Notice I got 3 different solutions for x, and that's because the highest exponent in my original was a 3. Alright, if you have a cubic, you're going to get 3 answers. Just like for a quadratic, when our highest exponent is 2, we get 2 answers. And last but certainly not least, question D, 2x cubed minus x squared minus 2x plus 1 equals 0. So I have a GCF of x squared. I'm left with 2x minus 1. Now, on the right, it might not look like there's a GCF, but you can always pull a 1 out, right? 1 is a factor of everything, but I'm actually going to pull out a negative 1 because my leading term is negative. So I'll pull out a negative 1, and I'll be left with 2x minus 1. So I've got a 2x minus 1. I'm left with x squared minus 1. And there's still more to factor because x squared minus 1 is the difference of perfect squares. I get x minus 1 and x plus 1. Alright, be careful. A lot of people like to forget that 1 is a perfect square. So 2x minus 1 equals 0. X minus 1 equals 0. X plus 1 equals 0. So x is equal to 1/2. X is equal to 1. Or x is equal to negative 1. And boom, done, so.